Hi, this is a quick presentation I've created called Polygons to Pi. We're going to be exploring some amazing things we can learn about a polygon as we increase its number of sides. To start, we need to only note two initial pieces of data: the number of sides the polygon contains and its radius, which is the distance from the center point to any vertex. Also, I wanted to mention that what I'll be doing here only applies to regular polygons, meaning that the measure of its radius is constant. Here we have a Google Sheet that I developed for this demonstration that's going to help us calculate the perimeter and area of our polygon. So the first thing to show you here is the variable n, which simply represents the number of sides contained in our polygon. You can see them here, and I put a lot of numbers there, both small and large. And that's going to be important when later we are drawing conclusions from the data we're going to calculate. So the next thing to show you is the variable capital N, which is equal to the number of sides times the sine of 180 divided by the number of sides. And if you're wondering why you're seeing the sine function, later we'll see the cosine function, that is because essentially the way we are measuring our polygon to get these results is by breaking it down into smaller triangles. And I'm not going to explain all the details of how we're doing that. There's an illustration here of that process, but I simply wanted to explain why you're seeing those functions related to a triangle. So now going back to n, I'm going to pull down the formula, and you can see as it calculates n for polygons with as many sides as it says on the left there. Now, the formula for the perimeter of our polygon is 2nr. Now, the important thing here is to recognize the similarity to the formula for the circumference of a circle, which is 2 pi r, 2 times pi times the radius. Now, the interesting thing is that n begins to approach pi. The more sides we have on our polygon, the closer n, the variable n, comes to pi. And this makes sense if you think about what a circle is. A circle has essentially an infinite number of sides. There's an infinite number of points on a circle's circumference. And so as we add more and more and more sides to our polygon, we're going to begin to approach and come closer and closer to a circle, which is why n comes closer and closer to pi, which makes sense when you look at the formulas. Moving on to our variable m, which is equal to the number of sides times the sine of 180 divided by the number of sides times the cosine of 180 divided by the number of sides. And I'm going to take that formula, pull it down here. You can see the calculations. And m is important for calculating the area, because the formula for the area of our polygon is mr squared. Once again, you're going to notice the similarity to pi r squared, which is the formula for the area of a circle. And as we would expect, m, as we increase the number of sides, begins to approach pi. This is really cool, I thought, and just seeing how as we begin to approach a circle with our polygon, the individual variables in the formulas begin to approach pi. Now, there's one more thing I wanted to show you here, and that is the percent of error for m and n. So essentially, how close are m and n when we have a million sides for our polygon? How close are they to pi? And you can see here, those are two very, 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 very small percentages. Lots of zeros after the decimal point. And this is real pi right here that you can compare to. So I hope that you enjoyed watching this video. Thank you very much.